Hello and welcome back at the second part of the network layer. At the first part, we explained how the network layer uses IP protocols for reliable communication. We also explained the role of the major header fields in the IPv4 packet, also in the IPv6 packet. And now we will explain how network devices use routing table to direct packets to a destination network, and also we will see the function of fields in the routing table of a router. With both IP protocols, version 4 or version 6, packets are always created at the source host. The source host must be able to direct this packet to the destination host, and for doing this, each host and device create their own routing table. Another role of the network layer is to direct the packets between hosts, and the host can send a packet to itself, and this happens when a host pings itself by sending a packet to a special IPv4 address or IPv6, and which is referred to as the loopback interference. Ping is the loopback interference tests the TCP/IP protocol stack on the host. It can send a packet to the local host, and this is a destination host that is on the same local network as the sending host, and the source and destination hosts share the same network address. Can send a packet to a remote host, and this is a destination host on a remote network, and the source and destination host do not share the same network address. And here it is illustrated that PC1 is connecting to a local host on the same network and at the remote host at the remote network. Whether a packet is destined for a local host or a remote host is determined by the source and device. The source and device determines whether the destination IP address is on the same network as the source device itself or no. The method determining varies by IP version. In IPv4, the source devices use its own subnet mask along with its own IPv4 address and the destination IPv4 address to make the determination. And in IPv6, the local router advertises the local network addresses, prefixes to all devices on the network. In a home or business network, you may have several wired and wireless devices interconnected together using an intermediary device such as LAN switch or wireless access point. This intermediary device provides interconnection between local hosts on the local network. Local hosts can reach each other and share information without the need for any additional device. If a host is sending a packet to a device that is configured with the same IP network as the host device, the packet is simply forwarded out of the interface through the intermediary device and to the destination device directly. But in most situations, we want our devices to be able to connect beyond the local network segment, such as out to the other homes, business, and internet. Devices that are beyond the local network segment are known as remote hosts. When a source device sends a packet to a remote destination, then the help of a router and routing is needed. Routing is the process of identifying the best path to reach the destination. The router connected to the local network segment is referred to as a default gateway. The default gateway is the network device that can route traffic to other networks. If you use the analogy that a network is like a room, the default gateway is like a doorway. If you want to get to another room or network, you need to find this doorway. On a network, a default gateway is usually a router that has a local IP address in the same address range as other hosts on the local network. It can accept data into the local network and forward data out of the local network, and it routes traffic to other networks. A default gateway is required to send traffic outside the local network. Traffic cannot be forwarded outside the local network if there is no default gateway, or the default gateway address is not configured, or the default gateway is down. A host routing table will typically include a default gateway. In IPv4, the host receives the address of the default gateway either dynamically from the dynamic host configuration protocol, or it can be configured manually. The same, even in the IPv6, it can be configured manually, or the router advertises the default gateway address. And as you can see in this figure, we have the PC1 and PC2 that they have the same default gateway as 192.168.10.1, and it is the IP address of the interface at this router that it is connected to this local network. Having a default gateway configured creates a default route in the routing table of the PCs. A default route is the route or pathway that your computer will take when it tries to contact a remote network. Both PC1 and PC2 will have a default route to send all traffic destined to the remote network to the router 1. In a Windows host, if we use the command netstat-r and equivalent route print, we will be able to display the host routing table. Both of these commands will generate the same output, and the output may seem overwhelming at first, but it is fairly simple to understand. And as you can see here, after using the command netstat, there is displayed the routing table, and here it is only displayed the IPv4 route table, and by entering this command we will be able to display 3 sections related to the current TCP/IP network connection. We will be able to see the interface list, which it will display all the media access control address and assigned interface number of every network capable interface on the host, including Ethernet, Wi-Fi, and Bluetooth adapters. We will be able to see the IPv4 route table, where it will list all known IPv4 routes, including direct connection, local network, and local default route. And if it will be shown even the IPv6 route table, we will be able to see even the list of known IPv6 routes, including direct connection, local network, and local default routes. Most networks contain routers, which are intermediary devices that operate on the network layer, layer 3. Router also contain routing table. When a host sends a packet to another host, it consults its routing table to determine where to send the packet. And if the destination host is on a remote network, the packet is forwarded to the default gateway, which is usually the local router. And what happens when the packet arrives on a router interface? So to answer this question, we will need to know that the router examines the destination IP address of the packet and search its routing table to determine where to forward the packet. The routing table contains a list of all known network addresses and where to forward the packet. These entries are known as route entries or routes. The router will forward the packet using the best matching route entry. And if we will be referred to this figure, we see that the PC1 need to communicate with PC2, and they are not on the same local network. When the packet arrives at the router 1 through the Giga Ethernet interface, Router 1 will de-encapsulate the layer 2 Ethernet header and trailer, and he will examine the destination IPv4 address of the packet and search for the best match in its IPv4 routing table. The route entry indicates that this packet is needed to be forwarded to the router 2. The router 1 will encapsulate the packet into a new Ethernet header and trailer and forward the packets to the next hop, router 2. So it will encapsulate the packet with the same destination IPv4 address, but now we'll have a different MAC address for source and the destination. And the following table shows the routing table for the router 1. And as you can see here, it says that the network with the IP 10.1.1.0 can be reached via the router 2. The routing table of a router contains network route entries listing all the possible known network destinations. The routing table stores 3 types of route entries, and these are the directly connected network. These network route entries are active route interfaces. Router add a directly connected route when an interface is configured with an IP address and it is activated. Each router interface is connected to a different network segment. And if we refer to this figure, the directly connected network on the router 1 would be the network at 192.168.10.0/24 and the network 209.165.200.224/30. We have even the remote networks, and these networks route entries are connected to other routers. Routers learn about remote network either by being explicitly configured by an administrator or by exchanging route information using a dynamic routing protocol. And if we refer to the figure, the remote network in the router 1 and in the routing table would be the network at 10.1.1.0/24. We have even the default route is like a host. Most routers also include a default route entry, a gateway, or last resort. The default route is used when there is no better match in the IP routing table. And in the figure, the router 1 IPv4 routing table would be most likely include a default route to forward all packets to the router 2. A router can learn about remote network in one of these 2 ways. Manually is when the remote networks are manually entered into the route table using static routes, and dynamically, and this time they are automatically learned using a dynamic routing protocol. Static routes are route entries that are manually configured, and the figure shows an example of static route that was manually configured on the router 1. And the static route includes the remote network at the IP address of the next hop router. And as you can see here, the router 1 is manually configured with the static route to reach the destination 10.1.1.0/24 network. And if the path changes, router 1 will require a new static route. And if there is any change in the network topology, The static route is not automatically updated and must be manually reconfigured. For example, in the router 1 has a static route to reach the destination 10.1.1.0/24 via router 2. But if this path is no longer available or something happened, router 1 would need to be reconfigured with a new static route to reach this network via router 3. So need to use the router 3 to reach that one. And the router 3 would therefore need to have a route entry in its routing table to send packets to the destination host via router 2. But there is a disadvantage using the static route because it has this kind of characteristics. Must be configured manually, and the administrator needs to reconfigure a static route if there is a change in the topology and the static route is no longer viable. And also, a static route is appropriate for a small network and when there are a few or no redundant links. But imagine what will happen if there is a bigger network and with so many redundant links. You need to reconfigure the static route every time that a link fails. A dynamic routing protocol allows the routers to automatically learn about remote networks, including even a default route from other routers. Routers that use dynamic routing protocols automatically share routing information with other routers and compensate for any topology changes without involving the network administrator. And if there is a change in the network topology, routers share this information using the dynamic routing protocol and automatically update their routing table. Dynamic routing protocol includes Open Short Path First and Enhanced Interior Gateway Routing Protocol. And the figure shows an example of router 1 and router 2 that automatically share network information using the protocol Open Short Path First. And router 1, by using this protocol, lets the router 2 know about the network 192.168.10.0/24, and the router 2, by using this protocol, let the router know about the network that he is connected and the network 10.1.1.0/24. Basic information only requires the network administrator to enable the directly connected network with the dynamic routing protocol. The dynamic routing protocol will automatically discover remote networks, maintain up-to-date the routing information, choose the best path to determine the network, and attempt to find the new best path if the current path is no longer available. And when a router is manually configured with a static route or learns about a remote network dynamically using a dynamic routing protocol, the remote network address and next hop address are entered into the IP routing table. And if it is shown in this figure, if there is any changes in the network topology, the routers will automatically adjust and attempt to find a new best path. Router 1, router 2, and router 3 here in this network are using the dynamic routing protocol. And if there is any changes, they automatically adjust to find a new best path. It is common for some routers to use a combination of both static route and dynamic routing protocol when they to reach a destination. If we refer to this figure, we see that the router 2 is connected with internet. Therefore, the administrator will configure the router 1 with a default static route, which will send the packet to the router 2 when there is no specific entry in the router table that matches the destination IP address. Router 1 and router 2 are sharing information by using the Open Short Path First routing to advertise directly connected network. And if we use the command show IP route at the exec mode at the router, we will be able to see the routing table on a Cisco router. And with this command, we will be able to see the IPv4 routing table. And here it is listed the IPv4 routing table for the router 1. And the common route source include this code. For L, it stands for Directly Connected Local Interface IP Addresses. For C, stands for Directly Connected Network. And S stands for Static Route, which is manually configured by an administrator. And with the letter O, it is the route that it is found by using the Open Short Path First protocol, and with the letter D is the route that it is found by using the Enhanced Interior Gateway Routing protocol. The routing table displays all of the known IPv4 destination route for the router 1. A directly connected route is automatically created when a router interface is configured with IP address information and is activated. The router adds 2 entries with the code C, as you can see here, and L, as you can see here. The route entries also identify the exit interface to use to reach the network. The 2 directly connected networks in this example are the network 192.168.10.0/24 and the network, as it is listed even here, it is 209.165.200.224/30. Routers 1 and router 2 are also using the Open Short Path First dynamic routing protocol to exchange router information. In the example routing table, router 1 has a route entry for the network 10.1.1.0 network that is learned dynamically from the router 2 via the Open Short Path protocol, and it is listed here. A default route has a network address of all zeros, and for example here the IPv4 network address is listed with 0.0.0.0, and it is a static route entry in the routing table that begins with a code as S and a star. And here it is highlighted, and it's the gateway of the last resort for the network 0.0.0 for all the packets that do not have a matching destination IP address. So with the last 2 topics of how a host routes the packet and the functional fields in the routing table of a router, we are ending the module of the network layer. See you in the next session, and please do not forget to subscribe at this channel for those who are new, and hit the notification button for the new videos that will coming up.